section 1.5 vocabulary. Now, make sure this time I didn't screw up too much, and then I kind of zoomed in for you so you can make it easier to read. And also write this down in your notes. Don't forget, you can rewind, you can pause it, whenever you need to write things down. And make sure that you write these in your vocabulary packet. So let's get started here with the 1.5 vocabulary. And the first word here is we're dealing with adjacent angles. Now, again, if you remember, not every word might be on here. I might cover a couple here and there in another word as well. But we've already talked about angles, and now we're going to look at adjacent angles. So these are different angle pairings. So in other words, there are two angles that have a relationship to each other. So in this case, adjacent angles are two coplanar angles that have a common side and a common vertex, but no common interior points. Now, if you remember, an angle, if we draw an angle here, this is the interior, and these are the exteriors. Okay, so that's a key part to an adjacent angle, is that there is no common interior points. Essentially, adjacent angles are two angles that share the same vertex. They have a side in the middle that's the same, okay? And they're essentially right next to each other, all right? So as you look at this here, the angle 1 and angle 2 are adjacent angles. So I'm going to, again, zoom in and take a look at this here. And I'm going to put these in two different colors. All right, so let's go angle 1 first. Angle 1 is right here. Okay, so that's angle 1 in the yellow. Angle 2, I'm going to put in the blue, and angle 2, as you can see, is right here. Now, where you see the yellow and the blue, okay, where you see the yellow and the blue, this is the common side, and it happens to be a ray, okay, the common side. And then we have this guy right here is the vertex. Okay, so these guys are adjacent angles. Again, they're right next to each other, but they don't have common interior points. For example, if I look here, I put a dot here. This is on the inside of angle 2, but it's on the outside of angle 1. This point here in red is on the inside of angle 1, but it's on the outside of angle 2. Okay, so these are adjacent angles. They're adjacent angles because they share the common vertex and the common side. Now, if you look over here at this picture, okay, this picture right here, these two share a common side. And matter of fact, it's this guy right here. This is the common side that they share, but they don't have the same vertex. So in this case, here's the spot where that vertex is, and here's the other vertex. There's two vertices in this one. Those are not adjacent angles, okay? The other type of angle that you're going to look at are what we call overlapping angles, okay? So, for example, you'll see that, like if I use angle 2 here, the blue angle, all right? If I use angle 2 here, the blue angle, and then I'm going to make this a red angle, and I'm going to say I use the blue and I use the red, okay? So you see the blue and the red. Those are what we call overlapping angles, okay? They share a side, but notice, again, on this one here, if I use the interior, okay, if I use the interior here, and I see, okay, so the inside of angle 2 is right here. That's the inside of angle 2. It's also inside of the big angle, and you can't have common inside points, okay? So you have to be careful with inside and outside parts and overlapping parts, all right? So adjacent angles are not overlapping angles. All right, so let's take a look at the next one, vertical angles. Okay, vertical angles are two angles whose sides form pairs of opposite rays. Vertical angles are two angles whose sides form two pairs of opposite rays. A lot of times you'll see it, and you'll hear me say this, they form an X. Okay, these angles over here are vertical, and these angles are vertical. Okay, top, bottom, left, right. Now, of course, they'll always get to a point to where they'll, turn them around, and they won't always be top, bottom, left, right. But in this case, angle 1 and angle 2 are vertical angles. When you notice, these two essentially straight lines intersect, they form perfect V's. Okay, they form perfect V's. And then angles 3 and 4 are vertical angles. Next one, complementary angles. All right, complementary angles are two angles are complementary angles if the sum of their measures is 90 degrees. So if I take the two angles, I add them up. So if I could say angle 1 plus angle 2 is going to equal a total of 90 degrees together. Okay, so as you see here, in this case, angle HKI, which goes here, that's the 30-degree angle, and angle IKJ is the 60-degree angle. If I take those two and I add them up, they add up to 90 degrees, so they are complementary angles. Okay. HKI, that's a 30-degree angle, and EFG is also a 60-degree angle, so those two would be considered complementary angles. Two angles that add up to be 90 degrees. Okay, next one is supplementary angles. Okay, supplementary angles are two angles are supplementary if the sum of their measures add up to 90. So in this case, if I take two angles and I add them up, it's going to equal to 180 degrees, not 90 degrees. So supplementary is 180 degrees, or it's two angles that add up to be a straight line. Okay, so as you see here, angle MNP is 110, and angle ONP is 70. If you add those two angles up, it makes a straight line, or it makes 180 degrees. So supplementary angles are two angles that add up to be 180. Okay, linear pair. A linear pair, and we're going to talk about this a lot when we go through our examples, but a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So adjacent angles, that means it has to be one right next to each other. The non-common sides, which I'll put the non-common sides in this picture, is this side right there, and then this side. These are the non-common sides. This is the sides that they don't share. And if you notice that, those are opposite rays and they form a straight line. Okay, so in this case, angle 1 and angle 2 are a linear pair. Now, supplementary and linear pair are very similar, and yes, they more or less mean the same thing, but it's the vocabulary that they're going to use a lot of times. They'll ask you to identify a linear pair, identify two supplementary angles. Essentially, you're looking for the same kind of thing. Okay, so here, in this case, angle 1 and angle 2 are linear pair. All right, then we get to this one, and the angle bisector. An angle bisector is a ray that divides an angle into two congruent angles, no different than a segment bisector. Okay, so in this case, as you look at this picture, in this case, ray LN bisects angle KLM. So in other words, it cuts it into two equal parts. All right, so as you're looking at this, again, that means then that the two angles are congruent to each other. Angle KLN and angle NLM. They are congruent to each other if the ray bisects it. Okay, so an angle bisector is a ray that bisects an angle into two congruent angles. Okay, this should conclude your 1-5 vocabulary. Okay, concludes your 1-5 vocabulary. Make sure that you have these written down, and then you can move on to the next video.